Okay, so hi and welcome back to another very cool tutorial. This time we will talk about virtual green screen production and in a very specific way about tracking. The technology we are about to use is from the company Lightcraft technology, and they developed a pretty cool app called Jetset, which will allow us to take all our camera motion data from the shoot and will transform this into a virtual camera that will have the same motion path as our real camera and will implement all of this into Blender. So without further ado, let's get started. If you ever run into the topic of tracking, you might have run into some serious problems because tracking is a pretty technical thing and you need to consider a lot of different things. First of all, you need to take care about lens distortion. And lens distortion occurs when the straight lines of an image appear to be deformed or curved unnaturally. And actually there are three types of lens distortion, as you can see. So we got the barrel and the pincushion and the so-called waveform or mustache distortion. And it is important to note that every distortion is different depending on the quality and the character of the lens and whether the lens can be removed from the camera or not. And as a filmmaker, you want this aesthetic of a lens distortion. So in a very professional environment, you would use a lens grid in order to pre-shoot all the lenses that are used in the production and then, for example, create ST maps. You can do that in a program like Nuke in order to match the lens distortion and get better results in the tracking and in the implementation of digital assets. The second issue when it comes to tracking is depth of field and motion blur. Imagine you have a shot with a cool vintage lens, for example 50mm, which has a nice bokeh, and everything is blurred out except for the actor or actress in front of the camera, and then you roll the camera and move the camera through space. And really, it's pretty hard to get any usable tracking data from a shot like this. So once again, in a more professional way, you can use, for example, a witness cam, which is, for example, a GoPro or maybe even a 360 camera like the Insta360. And this video information can be then used in a program, for example, ThinThighs or Mocha Pro, in order to get better tracking results with your vintage 50mm lens. And this is where Jetset's approach comes into place. So in a nutshell, Jetset is using the iPhone technology and the LiDAR scanner in order to work kind of like a piggyback witness cam for the real production camera, and then uses the in-house software AutoShot not only to correct the offset between the iPhone and your production camera, but also prepare everything for the later post-production in your software package of choice, whether it's Nuke, After Effects, or in our case, Blender. Oof. Okay, so what do we need for this setup? First of all, we will need an iPhone Pro starting at version 12. I got my iPhone 13 from a back market sale. And as a next step, we will need the Axion CMOV 4K, which is a video transmitter monitoring adapter, and it will work as an interface between our iPhone and our production camera. Then you will need an iPhone cage in order to mount your iPhone to the rig. And then, as you can see, we got some rods, in this case from SmallRig, and a small clamp from NiceRig to hold our Axion CMOV 4K. Next, we will need a camera with an HDMI video output. This is where we can connect our Axion CMOV to the camera and to our iPhone. And last but not least, an iPhone cooler so that the Jetset app will not overheat our iPhone. Pretty important. Now it's time for the lens calibration. Therefore, we can go into the Jetset app and create a new project, which we will call Tutorial. And then it's time to tell the app which lens we will use on our production camera, in this case a Lumix 12mm. Therefore we will need the scene calibration to tell the app that we are using a Lumix 12mm. And we can use this feature in the Jetset Scene package, which comes for free for the first month. After that you will pay $80 a month, but you can cancel anytime. And what I advise you to have is some sort of carpet with a nice pattern, which makes it easier for the camera to detect different points. So start your Axion CMOV until the app detects the camera and you can see the image of the camera. Then we can go into our Jetset app, go into Cine Calibration and open up a new tab for a new lens we want to calibrate. And in order to start our calibration, we can hit Start. And now we can see two monitors, our Jetset app and our production camera. and then start to create test frames in order to match the iPhone and the production camera, so we can measure the offset between both cameras. And on the right side, you can see the detected points between the iPhone camera and the production camera. And if you're happy with the result, you can click Keep Frame. And the app advises you to have at least 8 different frames. And the best way to do that is go around the carpet and take different frames from different perspectives in order to calibrate your iPhone and your production camera in the best way. And after you picked up like at least 8 to 10 points, you can click on Save and give the preset a name. In this case, we want to call this Lumix 12mm, and we're good to go and save this. And don't worry, we just have to do this once for each project. And the calibration is being done in the software from Lightcraft, which is AutoShot. I'm pretty sure they will change the interface once everything is working correct. But anyway, the software is working and we can go under calibration. Once we open up the app, you can see that AutoShot immediately detects our iPhone. And then comes the most important step, which is the sensor width. If you're not sure about the sensor width, then you can check out the retailer page. In this case, I'm using the Blackmagic Cinema Camera 4K, and we have a sensor width of 18.96 millimeters. And then we can hit Calibrate. And you can see that AutoShot is doing everything automatically, and it will grab all the information, all the tracking points and all the data from the app, and will calibrate for us our Lumix 12mm lens. And once everything is finished, you can see that the calibration was pushed to Jetset, and we can double check in our GUI check. And there you can see kind of like a 3D scan, a version of our carpet, and you can see where the camera was taking different frames. So everything is fine and we're good to go. So now we have the correct offset between our iPhone camera and our production camera, and we can work with our Lumix 12mm preset inside of the Jetset app. And then it's time for our 3D environment. Ideally, you will already have some sort of 3D scene. In our case, a nice and moody harbor scene with a lot of different assets. And now we need to transform this into a workable scene in Jetset. Otherwise our iPhone would crash, so we need to reduce the amount of vertices, and we need to bring down the resolution of our texture maps and transform our shaders into emission shaders, so they don't need any 3D light. So first of all, bring down the amount of assets and break it down to the really necessary parts. Even though it's hard, kill all the details where you put a lot of love and effort into the scene. That's okay, we will not use this for the production later on. This is really only for Jetset, so we can focus on the necessary parts left in the scene. Pretty important at this point, save your file separately. So we will keep the original 3D scene and we will create our own version, and we'll call this previous Jetset. In this way we ensure that we just work non-destructively and can return to our later scene with all the details that we've killed. And then continue deleting all the unnecessary stuff until we are left with the bare bone of the scene. Just enough information so that we can orient ourselves in the green screen later on. Okay, so all that's left is our footbridge from the harbor, and now we can transform our materials into emission shaders. Therefore, let's open up our shade editor, and then you can see we have a normal PBR setup for our footbridge, and we only need our albedo map, so we can actually delete our normal map and our roughness in this case. We don't need that. Then we can isolate this one so we can see it better. And we can start manipulating our shader. And in order to make this work, we can open up our emission shader, and then we can plug our color from our albedo map directly into the color of the emission and kill the hue and saturation node. And then we can pump up the strength to 1. And all we have to do now is to bring down our base color to black. And this way we have a self-illuminating material which can work without any additional 3D lights, which is perfect for our Jetset app. And all we have to do now is repeat this process for all the other materials. So take the color, put the strength to 1, bring down the base color to black, and then we're good to go. Once this is done, we can close our shader. And here's a quick tip. In order to ensure we have a pretty small file size for Jetset, we can go up into File and then clean up all the unused data blocks. That will just kill all the texture maps and all the materials that are left in our Blender scene. And the last step before we can export everything is we want to create 2 more scene locators that will help navigating inside of the app. And we're doing that by creating an empty object. And pretty important for the app, we need to name this correctly. So you always need to name your empties scene log for location, and then underscore, and then give it a name. In this case, we want to call this front. And our second empty, which we will place on the side, we will name this scene log underscore side. And you will see later on why this is important. And now we can export our Blender scene. And therefore we will go into export, and then we will use the universal scene description, which is the format that Autoshot needs in order to transform this into a USDZ file. And we will create a new folder. We want to call this Jetset Harbor Previs. And then we will create two folders, one for our USD file and one for our later created USDZ file. You will see in a minute why. And then we can hit export and jump right into Autoshot. In Autoshot, we can go into the next section, which will be models. And the first thing that we can do is we can set our USD folder. So let's search for our created USD folder and hit OK. And then you can see that Autoshot already detects our Blender scene. And then we can do the same thing for our USDZ file. So go to set and just jump right into the USDZ file. And now we are ready to go. And the first thing that we can do is we can change our texture size, because we don't want to work with 4K textures inside of the Jetset app. So I highly recommend to set your texture size to maybe 512 by 512, and the program will do the resizing for us. Okay, and then we can select our file and we can click the button Make USDZ. And you can see in the console what the program is doing for us. So it will turn all our texture maps down to 512 by 512. And once this is done, you can see we got a USDZ file. And at this stage, we only have to open up our Jetset app once again until you see our client in the top. And once this is done, we can push our files to Jetset. And with this step, we successfully transformed our Blender file into the app. Inside of the app, we can open up the menu, go to models, and then click on open. And there we will find our harbor establishing shot previs. And once we open that up, we will find our harbor scene inside of the Jetset app. Pretty cool, huh? And if we like to change the perspective, we can go into our side navigation, which we established with our empty, as you remember. And now we can switch between front and side and better control the environment within our green screen. And now with this setup, we are ready for the next stage, which is the actual shooting. So depending on the project, every green screen setup is a little bit different. In this case, we used a few LED lights to motivate our light in the 3D scene. And then we had a camera track with our camera rig, and the camera tracks are leading to our green screen setup with a few red tracking markers just in case things would have turned out bad. Before we shoot, I highly recommend to take a 3D scan of your green screen setup. This will maybe later on help in the refinement stage of our pixel tracking. And all we have to do is to click on Set and then start the scan, and the app will use the LiDAR scanner of our iPhone Pro and will do a pretty good job of a pretty rough 3D scan, which will, like I said before, later on maybe help in the tracking stage. And once you're happy with the scan, we can stop the scan and click on hide, so we don't need to see that. And we can pick a color for our green screen, so the keying inside of the app is as good as possible. But this is once again just a visualization for our shoot. But as you can see, the app is doing a fantastic job detecting our green screen. At this point, everything works like a normal green screen shoot, except that we will need a digital slate in order to sync up our iPhone to our production camera. Therefore, you will need some sort of tablet or laptop with the Autoshot software. Pretty important note, the laptop and the iPhone with the Jetset app need to have the same network or Wi-Fi setup in order to work correctly. And only when both gears are turned on, we will be able to open up our digital slate. And once everybody on set is ready, we can click on our Autoshot software, and there you will find the button Open Web Page. And this will open up a digital slate that will help to sync our iPhone and the camera image. And now we are ready for the first take. So turn on your Axion CMO until you see the live view inside of your iPhone. Then open up the Jetset app and point the iPhone and your production camera to the digital slate. Once everything is ready, you can hit record on your production camera and then on your iPhone, and all of a sudden you see these markers that will help to sync up both images together, and then we can roll the take. And actually, that's all. For this example, we had 3 different takes, and it turns out that the first take was the best one. As you can see, Jetset will produce 2 more videos. So one is the original iPhone video, and the other one is a Jetset comp, where it tries to combine the green screen footage and our 3D background. And now we can go back into AutoShot and create our Blender scene. Okay, so we will go into our take section, the last one. And the first thing that we can do is we can set our project folder. In this case, as you can see, I've created an asset folder where I put the Blender file and our USD and our USDZ file just for organization purposes. And I've created a BRAW folder for the raw data of my Blackmagic camera. And this is everything we need to have. And then we can select our scene source folder, which is of course our BRAW folder. So just go into the BRAW folder and click OK. And the first thing that we can do is we can enable our Jetset app. So we have our client and we'll pick the day at which we shoot. In this case, it's this one. And then we can click sync. And AutoShot will sync our BRAW files with the Jetset files. And that will take some time. And if everything goes well, you can see we got our different takes from the Jetset app and our project and our day of the shoot. Perfect. As a next step, we want to scan our Blackmagic files because we need to have our scenery offset between our iPhone camera and the Blackmagic camera. But once we hit scan, you can see that there's a message popping up that we need to create proxy files. And I'm not pretty sure whether this is only for the Blackmagic or if this is happening to all camera data, especially when you have raw files. Anyway, you can use the BRAW proxy generator that comes for free with the studio version of DaVinci. So open that up and then we can select our BRAW folder and we can turn our files into proxy data. And when the process is finished, the proxy generator created a folder called proxy, and in there we will find MOV files which are based on our Blackmagic raw files. And that makes it a little bit more easy for AutoShot to handle. Then we can define our scene proxy folder, which is inside of our BRAW folder, inside of the proxies, and we hit OK. And this is the last step. And then all we have to do is to click scan, and AutoShot will try to find the right matches between our camera data and the Jetset app data. And we'll try to sync that up and create a scene offset. And if everything goes well, we'll have the exact offset between both cameras. Okay, and then there's the message popping up that our scene offset is about 4.250 frames. And you can see the exact same number up here. And the last step would be to tell AutoShot that it should create a Blender file for us with our source file of our USDZ folder. And we can append the scene and we can hit extract EXR as a preview for our Blender scene. And we can tell AutoShot to start the clip at 200 frames, so we skip the part with the digital slate. And now we can hit save and run and let AutoShot do its work. And if everything goes well, it will create a Blender file that looks like this. Okay, and here's our USDZ file once again, but synced with our Blackmagic stuff. So if we skip through the timeline, you can see that we have the exact same motion path as our Blackmagic camera on set. Isn't that great? So now we have everything tracked, everything is set up, and we have a perfect reference that looks like this. And as you can see, we got our scan, which we did before we shoot. And we have our camera, which is linked to an empty object, as you can see. And we have a special folder for our USDZ, which we can turn off. And other than that, it looks pretty great overall. Okay, so, and the question would be, what can we do with that? First of all, let's get rid of the green screen. So we can open up shader. And then we have this setup here. So we have our image sequence as an EXR. And we have this pretty cool color key here that comes with AutoShot. And we can define the green color here. So pick the color and then hit the color here on the screen. And then go back to our principled BSDF. So we have a better separation of our talent. And this looks a little bit cleaner. You have some options in AutoShot, for example, using XSpy to get an even better rotoscoping. But for this tutorial purposes, it's totally fine like this. And the most important feature is that our camera and our image is parented to an empty object, so we can scale this up and scale this down, we can move it through space, and because of this we can better control how we want to position our image sequence inside of our 3D scene, and this is pretty handy. And the most important question is, how can we transform this into our real 3D scene? So actually it's pretty simple. We can turn off our USDZ background, we don't need that anymore. And we can select everything with the box selection and hit copy. And then we can open up our 3D scene with all the nice details and all the assets. As you remember, we just saved a second version for our previous, but this is the original file. And then we can copy in all the Jetset data, maybe create a folder for this. And now we can start positioning our camera and our image sequence as we want because of the parenting with our empty object. So in this case, I need to scale this up a lot because my previous version was a little bit too big. So we need to scale up the camera and the image sequence in order to match the real world scale. And because everything is parented to the empty object, we don't destroy any of the animation and the motion path, so we can really use this as our main control and scale it up, move it in 3D space. In this case, I wanted the image sequence to start a little bit further back on the footbridge, and then really once again check the real world scale and try to match it with the real size of the different assets, so it looks a little bit more realistic. And this is a little bit of a back and forth, so I will speed things up here a little bit, but you get the idea. It's really simple and pretty forgiving. And remember, we just prepare our 3D scene here, because we will not use the EXR from Autoshot, we will do everything in After Effects. So the only thing we need to take care of is how the 3D scene and the background looks. And once we're happy with the overall result, we can hide our EXR sequence, we can hide our scan, and we can, for example, play around with the Autoshot camera, for example, adding in a little bit of depth of field for photorealism. Okay, so this is how our final 3D render will look like with the correct motion path. And now we can render this out as an image sequence. Because now we want to combine our green screen original footage with our 3D background with the correct motion path of our Blackmagic camera. And finally, inside of After Effects, we can do a little bit of tweaking here and there. So for example, we can use our key light tools in order to get rid of the green screen. And then, for example, use a mask in order to get rid of everything else around the green screen. Then we can add in our background render that we've created in Blender with the help of the motion path data from Jetset. So as you can see, as a proof, we have the exact same motion path for both layers, so they match up pretty well. And this is a pretty important step after all this hard work. And as a last step, we can add in a little bit of color, a little bit of post-processing stuff like optical compensation, and a little bit of blur here and there. We can add in a little bit of grain, and we add in a little bit of mist. And for final touches, we can, for example, use a letterbox, or just change the aspect ratio of our image, and then we have something like this. And as mentioned before, this is of course not for a 6-second shot. I assume that you use this workflow when you really want to work with virtual environments inside of a green screen with a moving camera and a lot of different shots and takes. Then this workflow is really a time saver for you. Okay, so thank you very much for your patience, and hopefully you will find some good information here. I wish you all the best for the Christmas time, and we will see us in the next tutorial.